It's me, myself, and I. We'll make it right out loud. Lately I've been going through the motion, struggling to get me out of bed. I'm not gonna lie, not gonna lie, it's just harder these days. But I put on a smile, I put on a smile and say, honestly, I'm trying to take it one day at a time. I've been here before, keep me out of my way, cause I'd like to be here tomorrow. I'm alright, I'm fine, I promise I won't give up without a fight. It's me, myself, and I. We'll make it right out of life. Yourself today if you can. It'll be fine. I'm up with my friend.
Hi everyone. Thank you so much. You're so on time for coming into this live that we are having now. Oh, I look so tiny today. I look so tiny. And hi everyone. Make sure that you download our LG. Okay, SG City College will give you the link to actually download the LG. So make sure that you download the LG, okay, via this link, and make sure that you have the LG right in front of you, or at least download it onto your iPad or iPhone or whichever resources or devices that you're using. Because in a short while, I'm going to use this to explain to you. So if you don't have it, you will be a little lost. Okay. All right. I actually prepared some experiment. I don't know if the camera can actually zoom out and then see the full space over here. Do you think the camera can zoom up, can see the space here? Yeah, so that they can see this little cute little thing that I've prepped for them. Okay, since we are also waiting for people to come on in. Okay. All right, zoom out. Yes, zoom out. And yes, zoom out. Yay, okay. Now, I have a few things that I set up. I hope that you can see over here as well. Now, you can see that today got a lot of setup because of the experiment that you're doing. Or I should say this chapter is pretty tough in a way. The reason it's tough is because it's a commonly tested last topic. And for the past 2 years, due to pandemic, it was taken out, all right, for combined science. But for pure, they actually got a chance to learn it. Okay, let me do this properly. I have this cute little heart ring here. I have a battery and very strong magnet. They are called duodenum magnet. This duodenum magnet has the ability to do something. Now you're learning about electromagnetism. So what does electromagnetism means? Electromagnetism actually means that where there's electricity with magnet, a force is created, and voila, I didn't turn it. I don't know if you all can see it. All right. Oh, they want me to put this closer to me. Is it? All right. So that you can see. So when there is electricity and there is magnet, a force is created. The force actually causes this thing to turn. Isn't this beautiful? You can actually play it at home. Okay, this coin, you can coin it at home. So next time during Valentine's Day, instead of wasting money to buy chocolates and flowers, impress your the other half by folding a heart shape. I think only this one will impress me. Okay, anyway, this is one thing that you will be learning today, which is electromagnetism. And not only that, okay, I have another huge setup. Okay, it's getting a little hot for this one. Okay, I don't know if you can see this. Okay, they asked me to move it closer here. I have 4 batteries here. Okay, 4 batteries, set it up. Okay, and I have things with a lot of wires. Coil around an iron coil. Can see this is iron coil. Okay, this is a soft iron and this is wires just coiled around it. Now, with wires alone, this thing is already called a solenoid. Without the iron core, which is this metal thing here, just with the wire itself, it's called a solenoid. Yeah, it's just a solenoid. Now, if can you see from here? Okay, let me use this one instead. Which one has more coils? Obviously, is this one that I have in my hand has more coins, this is lesser, right? Okay, so the one with more coins, if I pass electricity to it, guess what happened? They will become an electromagnet. Okay. Hey, those of you that's in already, please say hi to me. Type inside the chat. Okay. And hello, everybody. Yeah, I'm waiting for more people to come up. So as you're waiting, you see me do some experiment to know that what you're learning today. Now, the moment you pass electricity with 4 battery, this become a very strong electromagnet. Hey, hi Joshua, good to see you. Okay, now they become a very strong electromagnet. Let's see if how many, these are, can see, whoa, nails. Okay, let's see how many nails can they actually pick up. Is it a lot or very little? Okay, whoa, whoa. Okay, can you see? Whoa, it pick up quite a couple of them. Okay, whoa, 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 whoa. Yeah, okay. Wow. Can see? They pick up a lot of nails. Can see? Let me put it in this manner. This has more coil. All right. Hello. Okay, this has more coil. I'm going to show you another one with a lesser coil. Let's compare. Obviously, this one I'm holding has more coil. This one that's in front of me has lesser coil. All right, so I'm going to do this again. You see, the moment I remove the crocodile clip, what happened to all the pins? They just drop off because there's no more current. The moment there's no more current, this electromagnet doesn't work. So this magnet only works when there is current. When there's no current, this iron will no longer act as a magnet, or I should say an electromagnet. An electromagnet is like a temporary magnet. We're going to study later more about it later today, okay, in some of the questions, okay? So at this juncture, while we're waiting for more people to join us online, I know that some of you are just finishing up your dinner, so don't worry, okay? I'm going to show you another one. Now, this has more coin. Let's see what if the other one with this one. Okay, this is very visibly lesser coil. Okay, then I'm going to connect to the next part. So electricity passed through it. This whole rod become an electromagnet. Okay, immediately, because they have less coil, you notice that I cannot put up a lot of, oh dear, you see, because it's weaker, I cannot put up a lot of I cannot pick up a lot of nails, okay? It's just like 1 or 2 nails only. Can see? Oh dear, oh dear. And hi, Irfan, thank you for coming. Okay, you smell really good. Okay, cannot already because this is very less coil. Lesser coil, the power of this electromagnet also decreases. Well, how strong this electromagnet is really depends strongly on what? The number of coils. You have a lot of coils like this, wow, you become a very powerful electromagnet. So for those that are studying the pure physics, you will notice that, hey, this is so important because you will also learn this in your transformer. Okay, so let's put this down. All right, so this is cute little things that I prepped so that as we are waiting for more people to come online, they can see. Okay, I'm going to put this aside. Okay, my assistant will help me to bring all this aside. All right, okay. Okay, please help me bring all this aside. Okay, let's go straight down to your LG right now. So if you have your LG with you, please remember download. Okay, now the link is there. You need to download the LG so that you can follow through today's lesson because I prepared for you exercises including notes to help you better understanding this topic, magnetism and electromagnetism. Now you must bear in mind that when we are learning magnetism and electromagnetism, this topic is actually a commonly tested or commonly taught last topic for all school. So for the last 2 years, it was taken out due to pandemic. So people for the last 2 years during O level, they are not tested. So you didn't have a chance to actually learn about this. But it's a very, very interesting topic. And hi, Rakesh, good to see you again. Now, first question that I'm going to show you is over here. Let me clean this away. Okay, wow. It's actually page 2 of your LG. Okay, page 2 of your LG. So if you have your LG with you or you haven't downloaded, please quickly download it, okay? Please quickly download it into your iPad, phone, or any devices that will encourage you to actually better follow through the lesson. All right, ready? Let's begin this first question. Now the question goes like this. The diagram shows an electromagnet and a permanent magnet. So it's very obvious that which one is the electromagnet. The word electromagnet means I got electricity. So this portion here is actually my electromagnet, which is this one here. Okay, now when electricity pass through this magnet, immediately they will become an electromagnet. So how do you know which side is north, which side is south? So what do I need to know about it? Do not fret, I'm going to show you right now. Okay, now every time when you see a current, or I should say a circuit that is set up, step one, always remember to draw the direction of the conventional current. Conventional current. Conventional current. It flows from positive to negative. Positive to negative. And which is the positive side of the battery or the cell? It is the longer line. So this part is positive and this is negative. Current flow from positive to negative, go up, 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 down. Wow. Now they say the electromagnet attracts the permanent magnet. Electromagnet attract the permanent magnet. Then it goes on to say the permanent magnet is then removed and the three compass are placed around the electromagnet. They say this electromagnet attract this permanent magnet. Wow. What does it mean? Well, let me switch cam. Okay, as you can see, this is the same questions that we are seeing or we are tackling right now. However, this question is very, very kind because they say the electromagnet will attract the permanent magnet. This part is north. For this to attract north, we all know that opposite poles of a magnet attract. So obviously this part must be south. But they give you this positive, negative. We also know that by using this thing called the right hand grip rule, it will teach us where is my north and where is my south. So today I'm going to teach you a little bit about the right hand grip rule. Ready? So for example, this is your hand. As you can see, I put on a surgical glove and I have already a lot of arrows drawn here. Okay, now to better understand this part, please turn to LG page 9. So if you have your notes with you, please turn to LG page 9. Now over here, this part here is the direction of my current, my fingers. This is my thumb. If the current go up, okay, my thumb will point here. So let me put this aside first. Okay, if the currents go up, my thumb points here. My thumb will show you the direction of north, which is the north pole. If my thumb, if my fingers point downwards like this, my thumb points here. Means that this portion will be my north and this portion will be my south. Let us do an example. Okay, so get ready. Okay, get ready your fingers and your thumb. Make sure that you're doing your right hand, okay? This is your right hand. Everybody say right hand, okay? Yes, you have to repeat even though I can't hear you, but I know that some of you didn't repeat. Okay, but I can hear Haliza repeating right hand. Very good. Hi, Dusty Baman. Okay, now over here, can you see this is a rod and I have current going upwards. So using my right hand grip, so go up. See? Direction, direction same. Go up. My thumbs point at this part. So my north is at actually where? 1 or 2. Okay, if you know the answer, please type into the chat. It's quite obvious, right? It's quite obvious, right? Okay, so go up. So is my north number 1 or number 2? So is my north number 1 or number 2? Okay, if you know the answer, please type inside to the chat. Thank you, Dusty Banban. Okay, Dusty Banban say it's 1, so it's quite obvious this one. Thank you, thank you, thank you, thank you, Rakesh, and thank you, Joshua Yong. Okay, next one. Let's see the next question. Oh, these are the common question. Oh, Irfan, good job. Now, if you see over at this question here, the direction of current is different from what you see from this question. This question, they show you the direction upward. This one, they didn't. So what should I do? Do not fret. Okay, they give you this part. The starting is going from behind. Then the direction of current will come down. Come down. come down, 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 down. So you draw the direction of current, down, and go up, down, and up. So using your right hand grip, tell me where is the direction of north? Is it 1 or is it 2? Is it 1 or is it 2? Oh, Dusty Bamban, you're very fast. Okay, Dusty Bamban, you're very fast. Okay, so use the direction of your current so that you know where is it. Is it north? Is it 1 or is it 2? Is it 1 or is it 2? Okay, is it 1 or is it 2? Okay, yes, it's 2. So it goes like this. Okay. So the answer is actually 2. The answer is actually 2. The answer is 2. Very simple, right? Oh, very good. And remember, what hand is this? Okay, no hands. Okay, no hands. What hand is this? Let's see if you all remember. What hand is this? Let's go. Hi, Carissa. What hand is this? Is this you're learning which hand rule? What hand rule are you learning? Yes, it is the right hand grip rule. SG City College, you cannot say what hand is this. They will just say Selena's hand, Miss Selena's hand. Okay, nobody actually say that. Okay, I will have typed that. Okay, now very good. Can I have a piece of wire, please? Okay, now just now we learned. Let's recap. My fingers can represent the direction of the current. The thumb will point to north, depending on the direction of the current. Okay, depending on the direction of the current. So this one is easy. What if, okay, I give you something like this? Okay, now you see all this dot and cross. What does it mean? This look like a bullseye, right? Okay, now this dot means that the direction of the current is coming out of the paper. So this is pointing, a dot is coming out of the paper. A cross here means going into the page. Okay, now how do you remember? I know nowadays we don't use straw, okay, but last time when you still use straw, or you go to any of the restaurant or fast food center that sell cup drinks, soft drinks, you notice that the position where you poke in the straw, there's a cross there. The cross tell you that this is exactly the position that you poke or you place your straw in. Okay, so imagine this for this one here cross. The current, like this wire, is going into the page. Like this wire is going into the page. So my thumb now will be the direction of my current. Yes, you hear me correctly. Your thumb now will now be the direction of the current going in. And now my fingers will show you the direction of the magnetic field. Okay, and you can see the direction of the arrow that is drawn here on the glass, right? Clearly. So how will I draw? It will go like this. Can see? Very clear? Okay? Yeah. Then how about this one? Now, if you want to practice this one, you can actually turn to LG, okay, on your LG, which is page 9. You can see that I showed you over there. Now, next one coming this. For this one here, the direction of the current is coming out. So it's coming out of the page. So my thumb now points up. And this now, which is my finger, will now in turn become my magnetic field. So if you have a whiteboard with you or paper with you, do you want to draw and sketch out the direction and compare your answer with mine before I show you the answer? Well, okay, if this one is going upwards, this is the direction of my current. You can see that it's going this way, this way. So arrow here. Okay, this is clearer. And this one here, because thumb point upwards, direction of arrow is like that. Can you see here? Magnetic field. So this is the magnetic field. Oh, sorry, it's this way. I made a mistake. This way, yeah? Okay. So let's do a quick recap. Your fingers can act as your current, then your thumb will be a magnetic field, which is north. Or they can exchange the role. Like in this case over here, my thumb is my current, and the finger is my magnetic field. Okay, so this one, like this, going in like this. Okay, I'm sure everybody got it. So you got your right hand grip right already. Remember, every time you see a solenoid, use your right hand grip. Solenoid, right hand grip. Okay, let's try the questions now. Okay, now, this is a super interesting questions, and I really like it because they are kind, because they give you a lot of hint, but sometimes we just miss out the hint, and we thought that it's too simple to believe that it's so simple. Yeah, really. Okay, positive to negative, then that will show if I use the direction that I have taught you just now. If you use the thing that I taught you just now, my north will be here and my south will be here. Can see go up, north here, south here. So North Pole here, South Pole here. Let me remove my glove first so that you can see it much clearer. Okay, now, then they say they place a compass. Do you know that the compass will actually show you the exact direction of the magnetic field of a magnet? If this is north and south, compass go like this. Exactly the same. We know that the direction of the magnetic field line go from north to south. North to south. Can see? So when you place a compass there, the compass will show exactly in this direction. Looking at A, B, C, D, which one do you think is the correct answer? Which one do you think is the correct answer? Going out, coming in. Okay, going out, coming in. Oh, okay. Sorry, just now you all cannot see. Now it's better. Okay, so with that in mind, okay, tell me which one do you think is the correct answer? A, B, C, D. You want to make a pick? Let me redraw this diagram using my marker since people are still deciding and looking at it. You take time to understand this, okay? So let me write down north and south, arrow north to south, north to south, north to south. Sounds like going North Korea and South Korea like that. So funny. Okay. North to south, north to south. So which one do you think is the correct answer? If you know the correct answer, could you type inside the chat and let's see. So if you see very clearly, hey, the answer is quite clear. Dusty Banban, see again, Joshua Yong. Okay, Dusty Banban. Oh, Choi Yen. Hi. Hi. You see, coming out, the arrow must be straight, north to south. This is north to south. So they want the direction of the compass needle around the electromagnet. So the correct answer should be C, north to south, north to south, north to south. Okay, north to south. Hey, good save, Dusty Banban. Okay, with that in mind, let's go on to the next question. Let's see some more questions that are more interesting over here. And hi, some of you will be thinking today get to see my face. Hey, I'm back. Hi, good to see you guys. Hello. Hello. Okay, now next question. Okay, now you know, okay, let's see this question again. Okay, if just now you miss it out, I have a second chance to show you. Okay, not this one. This part here is really north and this part is really south because the direction of the current goes like this. A magnet will go from north to south. Chang chang. Let me use the pink color, north to south. Chang chang. Okay, so if you follow through, the only one that north to south is this one. So answer is C. Okay, so moving on to the next question. Question 10, which is your page 3 of your LG. All right. It looks very similar. Correct. But it's not. Okay? It looks similar, but it's not. That's a beautiful thing about the question. They recycle it, they change a little bit. However, if you know the concept, everything becomes easy peasy. So you just need to learn the concept. Get your concept right, okay? All right, let's continue. Now, here is an electromagnet AB consists of a coil of wire on a soft iron core. The coil is connected in series with a switch and a direct current supply as shown in the figure 10.1 here. One end of the electromagnet is close to the north pole of a bar magnet. Isn't this similar? Similar, right? You would think like, I thought we did that just now. Yeah, but they changed it to a long question. So if you watch the live now, and then you're thinking, wow, O level is not that difficult after all. Tell your friend now, ask them, give them the link, watch it, okay? So that they will be blessed, okay? They will benefit as well. Okay, share this with your friend, all right? Now, if you see very clearly over here, they ask you the current of in the electromagnet is switched on. State the effect on the bar magnet. Wow, this up another level. Okay, state the effect on this bar magnet. AB is a soft iron core. When current pass through it, current flow in, okay, positive to negative. Like I mentioned just now, step one, when you see this kind of question, do not fret. Always draw the direction of your current, which is the conventional current. Conventional current flow from positive to negative, which I'm doing now. Okay, so let me use a blue color. So go in, come down. This is the direction of the current coming back. So same thing, okay, use your right hand grip. Okay, before I change the cam, use your right hand grip. Okay, before I change the cam, use the direction, use your right hand grip and try to tell me your B is actually what pole. Is it the north or is it the south? Is it the north or is it the south? Your B, is it the north or is it the south? Your B is your north or is it south? Whoa, Dusty Bamba, nice work, man. Nice, Joshua. Thank you for always watching. So nice of you guys. Okay, so if you use the, I've switched cam already. Direction of current go up, downwards, coming back. Okay, if I use the right hand grip, over here, I should do this manner, and it's exactly the same, and my thumb point this way. So therefore, this side should be north, which is my part B. All of you got it. State the effect of the bar magnet. So if this is north and this is north, you learn in magnetic field or in magnets what is so special when the both sides are of the same pole. If both sides of the same pole, like poles will repel. So your answer here, like poles repel. There you go. You have the first answer done. Let's move on to the second part. They say the current in the coil of the magnet is now switched off. Okay, let's switch cam again. Hi, I'm back again over here. Okay. Yes. Wow, Rakesh, good job. And Dusty Bun, good job. Like, post, repel. To gain your mark, remember, answer the question by saying first, for magnet, like, post, repel. Since using my right hand grip rule, B is my north, and this is my south, like, post, repel. Therefore, what is the effect of it on the bar magnet? It will repel, but they just take the effect. You say that they will repel, you will get your 1 mark. If they say explain, state and explain. If I change this to a 2 marks question and I say state and explain, okay, it's getting hot in here. So state and explain, then you have to mention that like, post, repel, and using my right hand grip rule, this portion part B is north pole, like, post, repel, therefore they repel, okay? But this is only 1 mark. So by just saying that they repel, you get your full 1 mark. Very good. Well done. Next one, let's go. The current in the coil of the electromagnet is now switched off. Now it is off. No more current. Why the bar magnet here, which is attracted to the soft iron core. Okay, why the bar magnet is attracted to the soft iron core? This is a bar magnet here. Why? It will still attract to this soft iron. Now, it's a temporary magnet. Okay, when you switch off, let me clean this away so you have a cleaner sheet. Okay, now AB will only become a magnet if there's electricity. If there's no electricity, AB will just lose its magnetism. However, your bar magnet is still a magnet. a magnet will attract any magnetic material. Actually, when you're watching here, do you know what are some of the example of magnetic material? Yes, yes, Dusty Berman, you are good. Do you know some of the example of the magnetic material? I have a student by the name of Nisha. Okay, and I love this place in France called Nice. So I love to use this as an example. Remember Nice. Okay. There's really a place in France called Nice. It's not pronounced as nice. It's called Nice. I love that place. It's beautiful. Okay. Now remember this acronym called NICE. Not NICE, NICE. NICS. It ends with a S. Okay. NICS. N stands for nickel. Okay, nickel, iron, cobalt, and steel. These are all the magnetic material. Okay, NCIS. Actually, sounds like a show, but I remember it as Nice lah, Nice or Nisha. I have a student called Nisha. If she's watching, wow, I'm sending you my love. Thank you. Okay. Okay, let's come back to here. Now, the question here says the current in the coil is now of the electromagnet is now switched off. But why the bar magnet is now attracted? Just now it's repelled. Why is it attracted? Well, when the current is switched off, this thing, this AB is no longer electromagnet. It become a what? Magnetic material. So the magnet can attract a magnetic material. So just need to explain why. Because iron is a magnetic what material. Dusty Batman, you're so good. Okay, so what you say just now is correct. Chang 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 chang, chang 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 chang. Okay, so iron is a magnetic material. Therefore, when the bar magnet is brought near, okay, my handwriting is not as nice, okay, but I'm sure you can tell. Okay, it's brought near to the electromagnet, it will cause AB to become an induced magnet. Therefore, it will attract AB. Okay, so when the bar magnet is brought near to AB, it will cause AB, which is the iron, to become an induced magnet. Therefore, it will attract AB. Okay? All right, let's move on. Now, why the core of the electromagnet is a soft iron rather than steel? I love this question. Soft iron and steel. You notice in all the questions, they keep using the word soft iron. Let me adjust my hair. Hair messy. Okay, now many of the time they will say, sometimes they say use the word soft iron, sometimes they use steel. What is the difference? If there's a soft iron, means that there is this thing called a soft magnetic material, and the opposite of soft is hard magnetic material. Soft and hard. Now, if you turn with me to your LG, okay, on page 7, I give you an example, okay? Now, the soft magnetic material are usually iron. The hard magnetic material are steel, okay? Soft magnetic material are material that can be easily magnetized. They can easily have magnetic power. However, because they are soft magnetic material, they will also lose magnetism very quickly. And that is none other than iron. Okay, then how about hard magnetic material? Well, for the hard magnetic material, it's made of steel. Steel, very difficult to become magnet. Very hard to magnetize. However, once it become a magnet, wow, man, they will retain this magnetism for a longer time. So that is considered as a hard magnetic material. Okay, so that's why they are used as a permanent magnet. So soft iron, very easily magnetized, very easily demagnetized. Demagnetized as well. All right. So imagine yourself today. You want to use it as a doorbell. You press, then there's sound. You don't press it, no sound. You want to use a soft magnetic material as part of the equipment, or a hard magnetic material as part of the equipment. to make a doorbell, you need a magnet. So those of you that's watching, you think in your mind, doorbell need magnet one ah. Oh yeah. Doorbell need magnet. If you don't know, doorbell really need a magnet inside. Okay. Some of the doorbells are okay. So when you press it, then you zzz. Then if you don't press, no sound. Okay. So they actually has a electromagnet inside. Another thing inside your household that have an electromagnet is none other than this thing called. Let me finish this question before I move on. Why the core of the electromagnet is soft iron rather than steel? Because iron is a soft magnetic material. It can be easily magnetized and they can be easily demagnetized. When there's no electricity, they will lose its magnetism. That's your answer. I repeat again. They say why the core of the electromagnet is soft iron. Because soft iron can be easily magnetized when there's electricity, and when there's no electricity, they will lose its magnetism. That's why they use iron. However, for steel, they will retain its magnetism even when electricity is taken off them. Okay? So let's move on to the next question. Next up, I want to show you and introduce to you this thing called a circuit breaker. Wow, can you see that the circuit breaker is actually found at home? Okay, how many of you have seen this before? I'm sure you have seen this, right? If you don't know, can I tell you all household have it? Can you make sure that you know? Okay, you are science students, okay? So girls that are watching, we are highly intelligent being. We must make sure that we know so that in any cases, if there is a blackout, we know what to look out for, which is the circuit breaker that look like this. Okay, now what is inside a circuit breaker is this huge thing. Okay, this is an example of a setup. In any circuit breaker, okay, which is page 10 of your LG, in any circuit breaker, you will see that there is this thing called an electromagnet. What is the use of an electromagnet? As I mentioned, when there's electricity, then there will be magnetism. No electricity, no magnetism. So, very simple. A circuit breaker, like I mentioned here, is a safety device. It switches off when there's too much current. So, if there is a blackout, it means that one appliance at home in your house is using too much current. So, there will be a blackout. Okay. Now, it looks something like this. Make sure you know where is it. And over here is an example of the circuit breaker. Now, this question actually came out a couple of times in GCE O level. And many students will think that, well, there's so many things to memorize. Can you don't memorize this? Do not memorize, then you will think, then how? Understand, no? Look at the diagram because they can change this diagram. However, the concept remains the same. The concept is to use this thing called an electromagnet. So always go and find where is the electromagnet in this diagram. Now in this circuit breaker, I can see that this is the electromagnet. This is the electromagnet. When there's a lot of current flowing through this electromagnet, it will become a strong electromagnet. It will be so strong that it will attract this iron catch. When they attract this iron catch, this part here, the point of contact here at this portion will be broken off. Okay, you will go away. It will be broken off. When it's broken off, there's no contact. That's when the whole household will have a blackout. Yeah, because this thing, no contact, this part will push the reset button upwards. When the reset button goes upward, you suddenly hear a tuck sound, really a tuck sound, and then the whole place is blackout. Okay, this is how it works. One question came out in GCE O level that looked exactly like this. And your job is to explain how this works. Okay, and it's also found in your LG page 15. Okay, so if you actually know the answer and you actually take time to write it down, okay, SG City College will send you this email. Send your answer to this email address, okay, and they will we will receive it, our reply to, okay? So type in an email and then they will send it in. If you wanna, okay, for me to check your answer, type it inside and then they will send me this your answer. Then I will check and I'll reply to via the email. Okay, so this is electromagnet, okay? Sorry, this is circuit breaker. So take a look at this diagram, okay? Before you type in your answer and get so excited. I want to answer so that I can get freebies, okay? So that Miss Selena can email me personally. Whoa. Okay, wait. Calm down, calm down. Whoa, calm down. Okay, calm down. Okay, let's look at this question over here. Okay, let me explain to you how this works. Very simple. First step for any circuit breaker, look for what? Tell me, look for what? Look for your electromagnet. Can you see that this part here is the electromagnet? So this is the electromagnet. When a lot of current flow through this electromagnet, the electromagnet will become so strong that they will attract who? Magnet attract what? Magnetic material. Who is a magnetic material here? It's just beside this one. Attract this. Then what will happen to the contact? The contact initially is in contact. Okay, then, oh, Dusty Bun, love your answer. The moment it is attracted, the contact will be broken. When the contact broken, okay, this spring will go up like that. Whoa. Okay, that's when you have a blackout. Okay, so answer the question in steps. I don't want to explain so much already. Okay, answer the question in step. If you know the answer, write it down already. Send it to info@citycollege.edu.sg. Okay, and then we will reply you back. Okay, I will reply you. Don't scared. Okay, let's move on to the next question. Okay. Next question that look like this. Oh, page 4 of your LG. Most interesting question coming up. They say that a copper wire carrying a current is held between poles of two magnets. You have magnet and you have a wire. This is wire. The current in the wire can be reversed. Imagine there's current flowing through here, and there can also be current flowing opposite because they say the current in the wire can be reversed. The pole of the magnet can be reversed. Oh man, wow, magnet also can reverse. Oh dear, oh dear. How many of the 4 directions shown by the arrow can a force act on the wire? OMG, right? You will be thinking, oh man, what must I do? What is the correct way? Do not fret. Today, before we end this live, we need to make sure that you know this thing called the Fleming left hand rule. So get ready to change cam. And hello, everybody. And you see my hand. My hand is talking to everyone right now. Okay, this is the hand. Okay, good hand and hand. Say hello to everybody. Okay, now this is my left hand. Okay, this is Fleming left hand. This is my which hand? Left hand. What hand again? Left hand. This is left hand. Okay, make sure that you're using your left hand. Okay, now a lot of my students always do this. Okay, this is my thumb, index finger, and your middle finger. Okay, it feels quite good just to do it in this manner. I have one student, very cute. He did this. Ayo, so painful. Okay, the moment you do this, can you feel the pain in your finger, your knuckles? Oh man, don't do that. It should just be like this. Rest nicely. Okay, steady. Okay, you don't feel the pain. If your finger feel the pain, you are wrong already. Hi yo. Okay, now the thumb here represent your force. Your index finger here represent your magnetic field. North in the inside, south at the outside. Current is your middle finger. This is the only time in school you can point a middle finger at anyone using this hand rule, and no one is going to scold you. That's a brilliant thing. Okay, let's practice. Okay, first one, let's say this one over here. Okay, I have a question over here. Now, I actually gave you a couple of practices also inside your LG. The LG page 13 will be your Fleming left hand rule practice. Okay, so imagine I have this north and south. Okay, the cross represent current flowing into the page, current flowing in, middle finger point inside, north and south, my thumb points downwards. Can see middle finger, Middle finger, point inside, north and south, north and south. Okay, my thumb point downwards. Okay, so therefore, the force acting is downwards. All right, those of you that's watching, please use your fingers. Okay, remember it's Fleming left hand and make sure that you got it correct. Okay, let's try the next one. Over here is the next question. Okay, this time round is still north to south, my magnet. Okay, can see, yeah? Okay, north to south. However, now, okay, sorry, it should be this way. Okay, now I change my magnetic field. Okay, south here, north here. Okay, so but current flowing out of the paper, my middle finger pointing at me. Okay, however, this part here is north, this part here is south. So what should I do? Should I turn and do yoga on my hand? No, you don't have to do yoga on your hand. Okay, some of you are very not flexible, you get a little bit frenzied. Do not scare. Just need to turn your paper. Can you see? Middle finger pointing at you. This is north, this is south. So what should I do? Don't fret. Turn your paper. Turn the paper north and south. Can see north and south. Middle finger pointing out at me. My thumb point upwards. Okay, can see north and south. North, south. Middle finger point at me. Thumb point upwards. There you go. This is the answer. There are more exercises on page 13 of the LG. You just need to turn to it and see. Now, so imagine this is the question. Okay, this is exactly the questions that we are dealing with just now. Okay, I'm not going to remove my gloves. Okay, so we're going to go through this again. All right, so let's see. Okay, very good. Okay, can you see now? Okay, make sure that you turn to this page of the LG. Okay, the LG page number 4 of the LG, all right? So they say how many direction? Let's say this is north-south. Let's say that the direction is pointing at me, okay, this way. So north-south, north-south, direction of current here. My thumb point where? North-south, direction of current in this direction. Thumb point upwards. So the wire will go upwards in this manner. Okay, now they say, what if the current is reversed? Don't fret. Current reverse, current go here, lor. Okay, can see instead of here, they go this way. Instead of this way, you turn your finger down. Hey, my thumb point where? Instead of this way, now the current go upwards. So I'm going to use another color pen. Give me a second where I use another color pen to come over. Okay, I'm going to use a marker, okay, to show you that it goes upwards, okay. So, like this. You notice that my thumb now point downwards, okay, thumb point downwards. All right, downwards. So there are two directions. Then they say, what if the pole of the magnet can be reversed? So I reverse it. So imagine current flowing at the red color. Now it is south and it is north. Okay, does it change a lot? Okay, let me do this so that I have a little bit more space to play with because I'm going to tilt the paper. Now, just now, imagine, okay, my finger goes here because the middle finger is the current. This is the index. Just now is north here, south here. However, now the south is here, north is here. So what do I do? Current still here. This is the middle finger. This is my middle finger. This is my current. These two are the same, but this is north and this is south. But here is north now. So what do I do? Switch. Okay, north, south. You notice that the thumb point downwards. Okay, got it? So immediately I know whether I swap the pole of the magnet or or I should say reverse the current or reverse the pole of the magnet, how many direction can the force act on? It's either up or down, lor. So how many direction is that? Only two. So no matter what, it's either up or either down. Either up or either down. So the answer is just two. Answer B. All right, let's switch a camera. Now, page. Hi, we are back again. Oh, Dusty Baman and Rakesh, good job. It's quite an easy question, because this question, just now that question over here, okay? Now they ask you, what if I switch the pole or switch the direction of the current? End up, it's still up or down, up or down. So even though it looks very scary, at the end of the day, if you understand the concept, it's either up or down, or how many more you can switch, correct or not? Okay, so isn't that easy? Okay, let's go on. So can I tell you, for this year O level MCQ, the last question is confirm what you are going through today, what we are going through today. So because you're watching, I'm sure, okay, you will get your 1 mark for the last question. Okay, let's move on to the next question. Now this is at page 5 of your LG. Okay, I think I still have a little bit time for this question. Okay, step 1, they say, whoa, the coil of the wire here, ABCD, is connected to a battery and held between poles of a magnet, as shown in figure 9.1. This is the figure. This is an actual GCE O-level question. Okay, let's see what they say. Draw an arrow on side BC to show the direction of the conventional current. Well, conventional current, as I mentioned, it could flow from positive to negative. So the long one is positive, the short one is negative. Positive to negative. Whoa, I show the entire. So the arrow for BC is this. So if you show this, you are correct. Got it? All right. So this is the correct one, BC, conventional current. I get myself 1 mark. Yay. Yes. Now draw arrow on side AB and CD to show the direction of force acting on the coil. So ready? Let's switch cam and let's go back to this portion here. Okay, same thing. Okay, so some of you will be thinking, should I draw my hand on actual O level? I think can, but you cannot draw before you enter. If you have nothing to do and you start to scribble on your hand, I think they will not stop you lah. Okay. Okay, positive to negative, positive to negative. Okay, and like this. Okay, so BC is this direction. They say draw arrow on AB to show the direction of the force. So obviously, is to use Fleming left-hand rule. Actually, do you all know this is actually called motor effect. So remember, next time when there is a magnet and there's current, a force is created. And that is none other than called the motor effect. Okay, so ready? Okay, get ready your finger, north to south. Okay, north to south. My current here, okay, let me use a black color marker because the middle part is the black color. So I draw here so that you all can see much clearer. Okay, so this part here, okay, north to south, if current is flowing this direction, north to south, current flowing this direction. All right, it shows that my thumb is pointing upwards. Can see? My palm is pointing upwards. My thumb is pointing upwards, so I draw upwards. There you go. Now, let's do the other one, north to south here. Okay, but the current is the opposite side here. Can see? Okay, so what do? I want to I just actually don't need. I just need to do this. Isn't this easier? Okay, north to south. Okay, north to south. Current here, can see. North to south. North to south. And my thumb is pointing downwards. So this way is downwards. And there you go. This is the arrow for AB and CD. And because of this downwards and upwards direction, you will notice one very important thing. At the end of the day, this whole thing will turn. That's why this is a motor, and this is called a motor effect. So this is Fleming left-hand rule. Okay, we have one last question. Okay, it's on the next page of your LG. Okay, so if you have the page number, can someone tell me the page number for this? Okay. Okay, same thing. Okay, let's not waste time. The coil ABCD is free to rotate about the axis of the rotation XY over here in the magnetic field of a permanent magnet, this too. By considering the direction of current and force, explain why there is a turning effect. So same thing, you use Fleming left-hand rule. So how do you explain? Well, using Fleming left-hand rule, Can you see they give a direction of current? Go up, come down, come down. Okay, so same thing. Current go here. Sorry, current go here. Magnetic field go here. So current go here. Magnetic field north to south. Current is here. This part go up. Okay, now because this one, the current go in, north to south is here, my thumb goes down. Did you get this part? Okay, I let you all see first. Thank you. Page 6 of the LG. Joshua, you're so good. So good. So good. So good. Okay. Can see? All right. So, then how do you explain? Well, using Fleming left-hand rule, you have to say, using Fleming left-hand rule on the coil AB, okay, you will notice that your thumb is pointing downwards. And using Fleming left-hand rule, DC, the thumb is pointing upwards. Therefore, it will cause this is called a clockwise or anti-clockwise. This is an anti-clockwise rotation about XY. Therefore, this ABCD will turn. All right, so let me repeat again. Okay, using Fleming left-hand rule, you can see over here. Okay, let's try one more time. Okay, in case those people that are watching, some of us that's watching, you miss out what I say, whether the north or the downward part or the downward part, upward part or the downward part. Okay, north to south, thumb pointing here. This part go upward. North to south, the thumb, can you see? It goes in. So current cannot be here. Current is the other side. So everything remain. Tilt it downwards here. Can see? Current go here. North to south. This one go downwards. AB is downward, CD is upward. So first, how do you explain? First, explain using Fleming left-hand rule on AB, the direction, and using Fleming left-hand rule on CD, the direction. Then you can say that one is upward, one is downward. So therefore, this whole ABCD will turn anti-clockwise. Therefore, there is a turning effect. And there you go. Okay, we have a good time. All right, let's go back to our LG switch cam. Hi, my hands and fingers are still here. Okay, I know that this is a very difficult topic because you have to visualize, especially when the diagram given to you is 2D, and you have to visualize it in a 3D manner. So sometimes it's a little bit difficult. So I feel that if by practice and with practice, you will actually get it better. And I hope that today's lesson with using the glove and using my point of view to show you the how to maneuver your finger will help. Remember, you don't need to keep turning. Turn your paper. You saw how I turned the paper just now. Okay, you can do the same because the paper is for you to turn in the exam. All right, so let's see. With that, we have finished the entire live for today for electromagnetism. So if you have question, okay, please ask first. I purposefully end on time because I know that this is slightly difficult and I know that people will be asking questions. Okay, so if you have questions, please ask us now. We will stay on a little longer to make sure that we answer to all your questions. Dusty Mama, thank you. Joshua Yo, thank you so much. Thank you so much. Now, this is the this is the fourth time that we are hosting live. We hope that the live has been useful to all of you. Now, if you still want more topics and more physics topics and chemistry topics to go through before your GCE O-level exam, please write to us, okay? Type in the comments, okay? Because we're going to upload this live very quickly, all right? And don't forget, just during the September holiday, we actually have 1 week of holiday, right? So we are hosting, or I should say, City College actually is conducting practical session with me. Yours truly. We are conducting chemistry and physics practical. And if you are interested, please sign up on the 29th of August to the 2nd of September. We're going to have intensive practical session This practical session is to equip you to have more confidence to enter the exam hall. You know exactly what to do. If people ever tell you that no need to study for practical, no, you can. There is a way, there is a method, and you can go in and do it confidently. All right. So if you're interested, please go to the website, and because you're watching live, I'm going to give you a good discount. So the discount code is love Selena. Love Selena. Okay? Love Selena. Oh, Joshua Young, you know the discount code. Thank you very much. So type in Love Selena and I'll give you a good discount. All right. So thank you so much for watching. If you want some more of the topics, please write to us. Thank you. Thank you. And have a good night and see you next time on live.